Good afternoon, everybody. Hi, how are you? Today I am going to give a lecture on high pressure homogenization, which has a wide application in dairy industry as well as food processing industry. Now, I have to know, or you have to know, what is the homogenization. What do you mean by homogenization? From the name itself, you can understand homogenization means everything will be in uniform size or uniform properties. So homogenization, if you want to define, so it will be a process of size reduction by which solid, liquid or gas phase will be dispersed in a continuous phase. If I am going to give an example, suppose milk. Milk is an emulsion, oil in water emulsion. Why? Because in case of milk, there will be two phases. One is continuous phase, another is dispersed phase. Continuous phase is consisting of water. Not only water, water along with protein, salts, in which fat remains in dispersed phase, which is in a less quantity. Okay. Contrary, if we another thing, suppose butter. Butter is known as the water in oil emulsion, where oil is in continuous phase and inside the oil there will be water droplets will be in dispersed phase. So this is the thing. So whenever there will be dispersed phase, any liquids or any solid particles or any gaseous material, suppose fog. Fog is also an emulsion where dust particles will be in dispersed phase in air, solid particles or dust particles. Similarly, aerosol is an also emulsion where it will be different liquid or solid materials will be in dispersed phase in gases as a continuous phase. So similarly, whenever this type of emulsion, similarly going to the size reduction process, so whatever the main material that is in you want to do the size reduction, that will be converted into the, or it will be converted in, or it will be transferred into the continuous phase. So in case of milk, where fat globules present in dispersed phase in very tiny particles, the size of the fat globules vary in between 0.1 to 20 micron. Predominant size of the fat globules is in between 3 to 4 micron. Okay. So if these fat globules remain in the milk, so what will happen? If we do not reduce the size of the fat globules, it will form a cream layer on the surface of the milk, and which will create rancidity, and which will be the responsible for spoilage of the milk. So prevent this, we have to reduce the fat globule size by some means that is known as the homogenization. Generally, in case of sterilized milk, the size of the fat globules should be kept less than 0.7 micron. If it is kept, then what will happen? That lower particle size of the fat globule will provide Brownian motion. And due to this Brownian motion, this will be randomly moved here and there. So there will be no possibility of forming cluster of fat globules or the formation of cream layer. Okay, this will prevent the formation of cream layer, as it will be prevent the milk from the spoilage. For this reason, we can store it for several weeks, sterilized milk. Okay, so this is the purpose of homogenization. Homogenization has also different or advantages. Just like in case of homogenization, what happens? A large number of fat globules are developed. So what will happen? It will scatter more light. So whiteness of the milk also increases. And due to the large number of fat globules, another things what happens, it will also shear force is also increases. Shear force also due to this increase in shear force, viscosity increases, and viscosity as well as temperature. Temperature of the temperature of the milk also increases about after homogenization and before homogenization. If the before homogenization, whatever the temperature, the after homogenization temperature of the milk also increases due to the friction of the milk with the valve surface. I am coming what is the principle of homogenization, high pressure homogenization. So temperature increases as well as gel strength. Strength of the milk also increases, which will be beneficial for the card formation, or that is in case of cheese formation, which is very much required for fermentation. So these are the things or advantages which happen in high pressure homogenization of milk. Another thing is that before going to or feeding the raw milk into the homogenization, that milk should be heated up above 65 degrees centigrade before to inactivate the lipase enzyme. Okay, this lipase enzyme, otherwise what will happen? This lipase enzyme can degrade the fat globule membrane, that is rancidity may occur. Okay, and another thing, fat globule, that fat globule also contains a membrane surrounding it. Okay, this fat globule membrane contains about 48% proteins, 33% phospholipids, and 19% water. Okay, so this protein coagulation takes place above 80 degrees centigrade if we heat the milk. So to prevent this, we have to heat above 65, below 80 before feeding the raw milk into the homogenization. This should be kept in mind. Generally, it is about 66-67 degrees centigrade it is heated up, and after homogenization, the temperature of the milk again it will be increased by about 6 to 7 degrees centigrade. Okay, now I am coming to the working principle of the homogenization. How does it work? Generally, homogenization is done by two stage double stage homogenization valve. One is first stage homogenization and second stage homogenization. In first stage homogenization valve, pressure is applied at high pressure, about 3000 psi, pounds per square inch, and second stage homogenization valve is operated at about 1/5 to 1/6 of the pressure applied on the first stage, about 500 psi, pounds per square inch. Now, what is the pounds if we want to convert? Generally, there is a relationship. If I want to share a whiteboard by this, we can show you that is how the existing homogenization works. That is, this is one type of two-stage homogenization valve. I think all of you have must be visible to all of you. This is the first stage homogenization. This is the first stage, and this is the second stage. Now raw milk. This is the raw milk, which is entering into the through a first stage homogenization valve through a high pressure plunger pump. This is the high pressure plunger pump. This is the high pressure plunger pump. Through this high pressure plunger pump, this is the pressure is about applied 300 psi, 3000 psi, sorry, 3000 means pounds per square inch. Now whenever this is the valve, this is the valve. Now this valve, what happens, it is made of three things. One is spring, along with this spring, this valve seat. All of you have seen, this is the valve seat. which is in the upper portion of the valve, and this is the valve body. These are the valve body. Now the milk is entering into the valve through the downward or from the bottom section of the valve. Now the force, upward force of the milk should be higher than the downward force provided by the spring. Otherwise, this valve set will not be moved upward direction, or there will not be gap between the valve body and the valve seat, and the milk cannot be flow. Why this type of things happen? Because whenever this velocity of the milk, or due to this high pressure, the velocity of the milk will be high, and it will give a high thrust or high shear force on the surface of the valve bed, so that it will be higher than the spring force which is provided downward direction, and valve, there will be a slit gap between the valve seat and valve body, and due to this reason the milk will be flowing radially in between two these gaps, and whenever the milk will be flowing radially, the milk will be seared. The milk will be seared. Seared means it will be create, or it will be feeling a shear force along the surface of the valve, and due to this shear rate, if the shear rate is very large, so what will happen? The milk, the fat globule present in the milk will be elongated. Suppose this is the fat globule. Fat globule, if you look at, this is the fat globule. Now, if the shear force is very high, so what will happen? After that, this fat globule will be elongated, means it will be just like elliptical. Okay, and again, what will happen? After some time, so there will be scratch, or there will be scribble will be done on the surface of the elongated fat globule, and due to this high pressure, what will happen? This elongated fat globule will be converted into the small fat globules of different numbers. Suppose this is the number 1 fat globule, this is the large radius, but after first stage homogenization valve it will be coming, then it will be converted into the, suppose, 3 numbers of fat globules with smaller size. This is the thing will happen. Okay, all of you have understood. So main thing is the shear force. Due to this shear force and shear stress, what will happen? Shear strain will occur, and due to this shear strain, fat globules will be elongated, and this elongation will be large enough, and there will be scratch formation or a ripples, that is known as the ripples, will be formed on the surface of the fat globules, and which will be responsible for the breaking down of the whole fat globule to the small numbers of fat globules. Now, why second stage homogenization valve is necessary? All of you have seen that after first stage homogenization, whenever it is coming out, then what is happening? The fat globules, after breaking down, it will be sticking to each other. That is, all of you have seen it. This is the sticking to each other. It will not be separated from each other. So, what will happen? To separate from each other, so that it will be looking like this small. So this is the separation. For this separation, what happens? The whatever the milk coming out from the first stage homogenization valve, it is again fed into the second stage homogenization valve. Okay, second stage homogenization valve, here you will get, after coming out from the second homogenization, it will be again converted, or it will be separated from the each other, and it will be freely from each other, and it will be flowing into the milk. So this is the thing, it will be happening in this thing. Okay, so this is the thing you have to know. So in this way, homogenization of the milk is done. This is the first stage and second stage. Now, first stage homogenization, and generally I have told you also earlier also that due to this, generally what happens, temperature of the milk is increased. Suppose if the milk is entering or feeding into the homogenization valve at 66 degrees centigrade, after homogenization it will be about 72 degrees centigrade. About 6 to 7 degrees centigrade it will be increasing. Why this increase of temperature will occur? Due to this frictional force. Frictional force in between homogenization valve seat and the milk surface. The milk surface, that is the fat globule. This is the fat globule membrane. If you look at this is the fat globule. This is the surface, fat globule membrane surface, and the valve seat. There will be frictional force will be occurring, and due to this frictional force, the temperature of the milk will be increasing. Okay. So for these things, now how to calculate? This can be calculated how much temperature will be increasing. By this, there is a small formula. By this you can calculate, that is the delta T. Delta T is equal to P by rho into Cp. Rho into Cp, where delta T is the temperature change in milk or increase in temperature. Temperature change in milk, and P is the pressure. Pressure at which the homogenization is operated. Generally this pressure unit is Pascal. Okay, and this is the rho. Rho is the density of the milk. Rho is the density of the milk, which is taken as generally almost same as water at 5, but it can be taken as 1010 or 1030. It will have kg per meter cube, and Cp of the milk about 3.9 or 3900 joule per kg Kelvin. If we take it, then you can calculate easily. Suppose if it is calculated 200 bar, then what is the relationship between pressure? There I have told you that psi bar Pascal. I have told you this will be the pressure in Pascal, so that you can calculate the temperature change in degree centigrade. So there is a relationship also in between pressure. If you know, then you can convert from one unit to or one dimension to another unit or one another dimension. So this is the one. Suppose one standard pressure, one standard atmospheric pressure, one standard atmospheric pressure is equal to 101325 Pascal. Okay, is equal to 1.01325 bar. Okay, is equal to 14.696 psi or pounds per 6, is equal to 760 torr or millimeter of Hg. Millimeter of Hg. So by this, or is equal to, there are different, these are the 1.03 kgf per centimeter square. kgf per centimeter square. So by this relationship you can calculate or you can convert. Suppose if anybody asks you what will be the 1 Pascal is equal to how much bar, or 1 bar is equal to how much Pascal, so you can, from this you can get 1 bar is equal to 10 to the power 5 Pascal. So okay, so whenever this 3000 psi, so what will be the thing, if we want to convert from psi to Pascal, so 1 psi will be 101325 divided by 14.696 Pascal. Okay, so 3000 psi, so it will be, if it is given in psi, so you can convert by this, and if you calculate, you can easily understand how much temperature will be increased by this. This is by this also you can also calculate the how much pressure. So P will be delta T into rho into C into P. Cp, specific heat capacity of the milk. It is generally 3900 joule per kg Kelvin. Okay. So by this equation we can calculate the temperature change or temperature rise of the milk. Okay, by this, now I have also told you what are the advantages. Generally, what are the advantages I have told? I have told is the different advantages. Wideness of the milk is increases. The temperature of the milk increases. Gel strength also increases. And due to this, that fat globule membrane, I have also told you that fat globule membrane, this fat globule membrane contains about 48%. Fat globule membrane contains 48%. This is the fat globule. So this fat globule membrane contains 48% protein, 33% phospholipids, and 19% water. 19% water. So what will happen due to this? Whenever this milk enters into the homogeneous, there will be interfacial tension also reduces between the fat globule membrane and this are surrounding liquids which is containing the in this continuous bed. And due this interfacial tension also helps to reduce the size of the fat globule membrane. Interfacial surface tension, that also is reduced. Okay, by this you can reduce the size of the fat globule membrane, and this is the purpose of the homogenization of the milk, so that we can increase the shelf life of the milk by about 10 to 15 days. Okay, generally sterilized milk, the diameter of the fat globule is kept about 0.7 micron, less than 0.7 micron, so that it can be kept for several weeks without any spoilage in milk, because it will provide the Brownian motion, and this Brownian motion will prevent the formation of the cream layer, which cream layer otherwise what will happen, it will create the rancidity. Okay, so this is all for today. Now how are you? Oh, all of you, how have you understood? That I will just, you can share with me. Okay, today I am ending. Best of luck.